Good afternoon. My name is Anthony Mesincho. I am a student on sport from Guayaquil, Ecuador. And in this presentation, we will explain the monitoring of a turkey hatchery based on a cyber physical system. This work was carried out in conjunction with the SDS group and colleagues from the Sport University. Next. These are the topics to be discussed. In the introduction, we will explain about the growth that poultry production is having in Latin America and the problems that this leads to as inefficient hatcheries. And here comes the importance of developing a system of low consumption, economic and functional, as the one we propose to solve these problems. We will also detail the main points of the relaxed work, the importance of this in our project. Then we will explain the methodology used for the end device, the gateway, how the communication between the embedded system is done, the data acquisition, and the design of the PD controller to control the temperature in our scale model. Finally, the results obtained we will explain, highlighting the computational resource and power consumption. Introduction. According to the Census National Corporation of Poultry Firms on Ecuador, Ecuador has the 10% of turkey production in Latin America, a number that is increasing. This increase has forced the implementation of industrialized and automated hatchery systems in order to improve the growth phase of turkeys and thus obtain the highest possible production. The main problem is that the automated hatcheries used in first world countries are very expensive and apply them in the country is not profitable. That is why we propose a cyber physical system based on a wireless sensor network with the objective of monitoring variables and controlling the most important of them. Our system will have the ability to send data to the cloud. It will be economical due to the low consumption of power and computational resource. This means that the end user will have an automatic control of the variables of interest. Next. Forest it all proposed an API for the control and monitoring of variables, which focus on a wireless network prototype that allows used to interactively manipulate the variables and adapt them to the user's requirements. So it all innovate with their project, the poultry production center, using a controller based on open hardware. And finally, Barrera et al. Explained the use of the Zigbee protocol for a wireless sensor network. Next. Introducing the explanation of the project. First, an exhaustive investigation of the parameters that are involved in the growth phase of the turkeys was performed. The most important of which are the temperature, ammonia levels in the environment, and lighting in the place. The optimum range established are those shown in the table. But before this, it was defined how many end devices will be used and their respective tasks. The end device 1 will be in charge of measuring the relative humidity and temperature in the environment. The end device 2 will measure the light intensity and ammonia levels in the environment. And finally, the end device 3 will be our PID controller for the temperature variable, which must be in the range shown in the table. Next. In the figure on the left, we can see the topology used. First, we go to the end device level. The end device used will be an Omega 328P microcontroller. The end device 1 and 2 was programmed in C language in order to optimize resource. This microcontroller will collect data through the sensors used, with, in the case of end device 1, is the DXD11 for temperature and humidity. For end device 2, LDER was used for lux and the NQ127 for ammonia levels. After collecting the data from the medium, the microcontroller and the XB antenna are linked through serial communication so that it can transmit the sense data through the Zigbee protocol. The end device 3 uses FreeRTAS in its programming, which allows to configure multitask to our microcontroller, and the advantage is that it is open source. This end device will collect data from the medium, in this case the temperature, through the LM35, and through the PD controller will act on the system to meet the user's requirement. The actuator in our system will be 55 watts X1 type halogen bulb. Later, my colleagues will explain these parts better. Finally, we have the gateway or coordinator, which is the Raspberry Pi 4B. It will be responsible for sending a series of frames to the three end device using the Zigbee protocol for wireless communication. It will also have the task of sending data to TeamSpeak every 15 seconds. These data are collected by the end device as we see in the picture. For communication between the Raspberry and the XBee antenna is used a Zigbee shield with USB port. Next, please. In this slide, we have the algorithms used in general for the end device 1 and 2 and for the gateway. For the end device 1 and 2, we present the following code for a better understanding. When the end device is enabled by a frame sent by the coordinator, it begins to perform its task. It starts counting on 0. When entering the while loop, it starts to accumulate data corresponding to the measurements of the temperature, humidity, and lux and ammonia levels for 50 seconds. After this time, it responds to the coordinator with another frame where it has the average information of the measurements taken during the 15 seconds. Then we have the coordinator, which is the Raspberry. When the program starts, it sends 3 frames, one for each device, for 15 seconds, goes into a sleep mode. After this time pace, the coordinator will do the following. First, request the average data to the end device 1 and 2, then extract the information sent by the end device because, as we say, it responds with a frame. Then the conditions are reviewed to finally publish this data in TeamSpeak. Then my colleague, Julio Alejandro, will explain what was be done in the end device tree.
Thank you, partner Anthony. This presentation is the methodology. So, to obtain the PID constants, the time is take for the temperature to stabilize when the light intensity is modified by means of voltage was obtained in open loop with varied between 0 to 7.451 voltage. This represents the input of the system, while its output varies between 28.8 Celsius to 62.98 Celsius respectively. The data were processed and entered into MATLAB system identification toolbox, where 7%, 70% of the signal was used for training while 30% was for validation. Then, in order to be accepted, a model of 81.34% was obtained, which is higher than 80%. In the attached image, we can notice the data acquisition process. Then, with the producer describe about the following constant we obtain, where the proportional part allow regulating the oscillation of the response with the value of 5.9843, while the integral decreases or eliminate the error in the state state with the value of the 0.81832. To finally not modify the speed of the response by the derivate constant. Therefore, the control is Pi. Obtain, obtaining the following characters. Here is observed the transfer function of the system obtained by means of the identification. This is of second order. Its response represents a subdamped system. The data when we perform the open loop test to perform the system identification area triple E cloud. The same that are shared with other users so that they can perform and complete cyber and say as required. The temporary data acquisition for two-character high-tech. This data link in risk. Then, a test process was performed in MATLAB to have a reference on the behavior of the system. As you can see in the graph, both positive and negative variations were performed, which obtain an excellent performance because the set point and the response are very similar. Then it was implemented in a shed where the turkeys were to have the efficiency of the data, which are shown in the right figure or picture. We can observe that the set temperature was 42 Celsius, where in the has a similar behavior to one simulated in MATLAB. The small values were tied to the noise that existed in the system. Result. Here we can see that with the respect to data memory, a similar scale is found around 40% of the total, while RAM varies around 20%. The one with the highest consumption of data memory and this RAM was the NDY3, which was the one contained the PI control. While the power is higher between the NDY3 and the Raspberry Pi, due to the fact that the one keeps the temperature set while the other is constant accessing the data to publish to the ThinkSpeed platform. This platform is the EOT. The highest power was approximately 2.70 watts from the coordinate is the relation in this picture. Discussion and conclusion. The project described about solves in the main deficits that occur in poultry farms in Ecuador. The use of AVR microcontrollers such as the Mega 3280P and hardware based on ARM Cortex A72 processors such as the Raspberry Pi 4B, working with the low power consumption and with maximum savings in downtime or idle operation mode. Two, by means of the MATLAB turbo system identification, the behavior of the plant was obtained experimentally. The same plant frequency was reduced by code in order not repeat the process. Remember that temperature is a slow variable and the very good response in this performance was obtained. Three, the memory used in each in the end device varies depending on the task assigned. In this case, when using the free R2S library, the programming consumes more computational resources because it is necessary to load the bootloader and assign a stack for each task prior to the use of the library. It is possible to adapt it according to the user requirement. For the use on embedded system allows the technology to be scalable and the resource efficient. The PI control, yes, the PI control embedded in the Atmega 328P microcontroller allows the system to have a better response time control of the temperature variable. Is the presentation. Finally, for more information please contact us. Where is the following information? Thank you very much in this presentation. Thank you, Anthony.
Thank you.